Okay, we've just got our new 2Q in stock and set one up here at the bench, and we're going to give it a test and let's see how we do. So what we're going to do today is go through a basic setup and show how we set for the different types of inverters we're going to connect to and some basic settings. So first thing we do is we connect to our device. In this case it's the REC BMS AP. And once we've done that, we type in 192.168.1.184. Now, if this is slow to log on, give it about an hour or so. The firmware is actually on the SD card in the Wi-Fi, and it takes a while for it to download and get ready. So if you're only getting partial pages, just give it a while, do a power cycle on it, and come back, and it should be fine. So we have no BMS. So keep in mind that you can have multiple BMSs on this network. So we have to go in and tell it which BMS we're talking to. So we go into the firmware setup and we have to select our send address. And now in this case it's going to be a 1, but we'll hit the find button. Give it about 10 seconds here and see what it comes back with. Okay, so it's found device number 1 out there and we hit set. Now we can see that we have our BMS info here. So we've got our BMS is 2Q0423 is our name. So we're going to use that information to log on. So 2Q dash exactly as you see it here, 0423. No thanks. Now we can see that it's been unlocked, and if we go back to our home page, we can see here that we have all of our data. We have our 2 additional opto outputs, which are configurable, and this is the auxiliary switch on the Wi-Fi module that you can use for things like turning on and off lights, for disabling an inverter, for whatever you wanted to do. It's just a remote controlled dry contact switch. Scroll down, we look at tasks. We'll come back to this one afterwards as a separate feature, but basically you can take each one of those optos and you can set them to control various parameters. Impedance, this is the internal cell resistance, and this is a calculated value. So this takes half a dozen full cycles or so before we actually get any valuable data out of it. We look at our temperatures. These are the internal. So our internal temperature is 23 and our external temperature is 23.4. We can of course add additional temperature sensors to that. We go into settings, and these are all the settings. Now if we do not have this submit button beside them, that means we haven't logged on. You only see that when you're logged on. The first thing we're going to do today is we're going to connect to our inverter. And that is not one of these standard settings. So what we're going to do is we're going to go back to the firmware page. We're going to scroll down till we see manual communication. Now we need to set the address. In this case it's address number 1. And we want to see what the CAN speed is. So we just type in CANS and a question mark. Hit the submit, and we can see that that's speed number 3, which in this case is speed number 3 is 500K. Now today we're going to be configuring it for an SMA. So we need to set the charger type, and we need to set the CAN speed. So if we look for SMA, we want to set a charge to 2 and our speed to 3. And that's as simple as type in, all in caps now, CHRG. Okay, so we have to put a space between that. So when you put the question mark there, you do not need a space, but you do need a space when you set it to a new value. Next we're going to do is just verify that our CAN speed, so CANS space And in this case, we want it to be 3. So can speed 3, submit. Okay, now we are set up and should be able to communicate with our inverter. A couple other parameters you will want to set up. So let's go back to settings. Your voltage settings are pretty well roughed in for most LiPo 4 or LFP type of batteries. You can tweak them a bit as needed here, but the areas we do need to focus on here are, one, our current settings. So what shunt are we using? So did you get a 200, a 300, a 500, or 1,000, or is it some custom value? And if it's a custom value, then you'll go in and set the coefficient. If it's a standard value, it will set the coefficient for you. Sensor offset is usually left at 0. And now we need to figure out what parameters we want to adjust for our inverter. So what's our maximum charging current per inverter? It defaults to 35, most are higher, but it's always good to start low. Maximum discharge current per inverter. Again, most of these are higher, but we'll start low. We set our maximum discharge current limits. So if you have this is normally set to about 1 to 2 C. The idea being is if you're drawing over 1,000 amps, something's wrong, so we're going to shut the system down. These are your standard charging and discharge coefficients. We pick our engineering units here, Fahrenheit or Celsius. And then we can set a minimum and maximum temperatures. The maximum allowed BMS temperature will disable your top balancing if it gets above this point. There are internal resistors within the BMS, and your BMS will start to get warm, trying to bleed off the excess capacity if the cells are not balanced for any reason. Next thing we're going to do is we're going to set our operational capacity. So let's say we have 16 230 amp Kelp cells. Our operational capacity will be 230 amps. If you had a 2-piece system with that, our operational capacity would be 460 amps. This can be reset, but right now we can show that we've had 2 battery cycles and we have 1 device connected to it, and we're using a standard LFP LiPo 4 chemistry. Now you are pretty much ready to be up and going. So we would then just come back to our home screen. We can see we're drawing 0.4 amps. Our minimum is 3.20 and our maximum is reverse that, is 1.48. I just grabbed some old cells here to get this going and they're not matched. Now the last part is we're going to come back to is tasks. And here you have 2 configurable outputs that you can use for inverters, for a low temperature alarm, for a low temperature heater, a high temperature alarm. You've got a lot of options here. So if we select output number 1, each one of these outputs is meant to drive an interlock type of system. If you want to run a contactor or a heavy load off of it, you'll want to add a small interposing relay. So let's say we want to trigger an alarm when the highest cell voltage exceeds a certain point. Okay, so we would go highest cell voltage would be off with an error or on with an error. We would set it if it goes above, let's say 3.7 volts, and with a 1/4 volt hysteresis. We can also include selected errors. So if any one of these errors is triggered, it will also trigger that alarm. And that's all there is to it. So we'd set up to number 2, and let's say we wanted to set on, let's say, a state of charge. Let's say when our batteries go below 50%. So we would just say compare, if it's 0.5, remember it's percent, with a 10% hysteresis. Let's make that 5%. We'll submit that. Oop. Didn't. So it's 0.5 and 0.05. So this output now will close. We could turn on a buzzer, an alarm, an indicator, something showing that our capacity's gone less than 50%. That's it for today, Joyce. Folks, I hope you enjoyed it.